Right, I've just done this really just to try and get your brains waking up and thinking about forensic science. Forensic science is any science pertaining to the law. So by definition, science is science, okay? So if you're studying science, but if that science links into the law in any way, then that's when it becomes forensic science. So forensic science has got a huge scope. People, when they think of forensic scientists, think of guys in the white suits, sort of sitting around, you know, collecting evidence at crime scenes, and think that that is forensic science. But in actual fact, it is so much more than that. These are just a few of the areas of forensic science. The one tiny part that people look at is perhaps this evidence collection bit. When I went to university and I went and applied to do a forensic science master's, so I did a master's in chemistry first of all. I then went into King's College London and did a master's in forensic science. And in the interview, and I had to interview for the place, they said to me, what do you think forensic science is? And what they were checking was that I didn't think it was people in white suits collecting evidence. Because in actual fact, they aren't the forensic scientists. They are people that work for the police who go and collect it. You can become a crime scene analyst, essentially, or a scene of crime officer, SOCO, with very few qualifications. It's not the same as an actual forensic scientist. So the people you see in the pictures aren't the forensic scientists. The forensic scientists are the ones behind the scenes. They're the ones that do all the analysis of all of this. You can be a very, and a misconception to these TV programmes, if any of you watch CSI, one scientist does every single bit of, you know, science. So they're an expert in blood, they're an expert in fingerprints, they're an expert in DNA, they're an expert in fibres. That's not really how it works. If any of you watch Dexter, Dexter is a blood spatter analyst. He looks at one very distinct part of forensic science. And that tends to be how scientists work, especially in the UK. Now, my area of expertise was forensic explosives. So I went on, during my master's, I had to apply. Can you get them quiet? For my master's, I went and did a work placement, and I got a placement at a forensic explosives laboratory. Now, that's part of the Ministry of Defence in the UK. Part of it's loads of acronyms. So I was part of the FEL, Forensic Explosives Laboratory, at the Defence Science and Technology Laboratory, DSTL, for part of the Ministry of Defence. What that actually meant, anything in the UK to do with explosives, so anything, it could be someone putting a firework through a letterbox or putting a firework in a post box, so no person necessarily affected, right up to the London bombings. So the bombings that happened in London Underground, it was my laboratory, a forensic explosives laboratory, that actually analysed and tried to find all of the evidence and collate all of the evidence to do with forensic explosives. But the laboratory that I worked in was one of its only kind in the world. Not one of a kind in the UK. The Trace laboratory there was the first of its kind. There might have been now, there might be more now, but the only kind only one of its kind in the whole world. And they got called to work in bombings all over the world. So I don't know, you're probably a bit young. You might remember, you might have heard people talk about the Bali bombings in 2002. Huge bombings. There was one inside, a primary device that went off. All of the tourists, it was a very touristy destination, were then all moved outside to get away from the bombs. And then a secondary device went off outside. And it was deliberately done to try and get everybody amassing in one area to get maximum casualties. People that worked at my laboratory were then called out to go and investigate and look at that. One of my ex-colleagues from the Forensic Explosives Laboratory is now working in Dubai, setting up the laboratories in the police in Dubai. So she is now getting a lab out here, accredited forensic science, to be able to do the processing for forensic explosives. The word contamination, can I see who knows the term contamination, familiar with it? Might have used it in science. It's one of those things that could be used in general. You're welcome to join us, by the way, if you want to. Okay. So contamination is when you've got unwanted pollution of something that is not supposed to be there. So it can be used in a whole general terms. If something is somewhere it shouldn't be, then we say it's contamination, it is contaminated. When it comes to evidence, when it comes to forensic science and you're analysing evidence, you generally get one piece. So in the Forensic Explosives Laboratory, we wouldn't know the big picture. We wouldn't get told what was happening in general. We would just get one piece of the evidence. So, for instance, this is our suspect here. Georgia Milligan is our suspect. We think that she has been handling explosives. So a senior crime officer will swab her hand. That piece of evidence, that swab, would be sent to me in the laboratory. I would analyse it and then say whether or not there is explosives on the hand. I have no idea what Georgia has been doing other than that. I don't know what other evidence there is to point towards it. I have that one singular piece of evidence that I analyse and report back on. If that crime scene is contaminated, if that evidence is contaminated, it's then inadmissible in court, which means it doesn't matter how good the science is. If I find, Malchior's blood in a fingerprint that Georgia has left behind, telling me that Georgia was there at the time that you were bleeding, and I match that DNA, but the evidence wasn't collected correctly, then it can't be used in court, so therefore it's no good as evidence. There are loads of different ways at a crime scene to try and make sure that you get evidence that is going to be able to stand up in court. These sorts of pictures, I'm sure, are familiar. You might have seen them on the news at some points. The first thing you do if there's a crime scene is you block it off. You stop access. If you have seen, thank you. It's very sensitive. I didn't even touch it then. If you've seen The Bone Collector, if you haven't, I recommend you watch The Bone Collector. It's by an author called Jeffrey Deaver, who writes very good forensic science books, very detailed. And there's a part of the scene where one of the scientists, police officers, finds a crime scene and it's in the middle of a train track, and she stops the trains and everything from coming in. Because as soon as something else gets in there, you're contaminating that crime scene. Science officers will set up a common point of access. So if you notice here, people walking all over the place will contaminate it. So the scientists will lay out a common entrance and exit path so that they are only going to be getting their footprints or in their fibres or skin or DNA only on that common path, making that this area over here is preserved. There would be someone on the edge of the crime scene tape logging people coming in and coming out. So if we find someone's footprint, is it there because we know that they've had access to the crime scene? As soon as you log any evidence, as soon as you collect any evidence, notice that we're wearing the forensic suits here. This is what I used to wear to work on a daily basis. Not to work, you didn't drive into work with it on, but when you get there, to stop any of your DNA or any of the fibres or anything on you, I'll talk a bit more about that in a minute, getting into the crime scene and stopping you from picking anything up from the crime scene. But with all of this, all of your boots, anything that is collected is bagged so that it's not going to be losing anything, but it has to be sealed and signed. There needs to be a chain of custody. So anything that is taken in has to be signed and pushed. Now, if I have a piece of evidence, the senior crime officer collects it, gives it to me as a scientist, I open it up, I have to reseal it and sign across and date it. And there needs to be a really clear log of that evidence. If at any point we don't know where that evidence was, it's inadmissible in court. It can't be used because somebody else could have tampered with it. Ladies and gents back there, can I ask you please to drop the volume? Thank you. So that contamination, that issue of contamination, that issue of chain of custody, and again, these are terms that you'll probably heard on TV if you watch any of these sort of CSI type programmes, but it is so important to make sure, because any gap in that would be something that the defence, so someone who is defending them will say you can't use that as evidence. Now, this became something that was really relevant to me when I was working in the Forensic Science Laboratory. I was only there for 2 years. You don't need to have all of the detail of this, but I put this on here and a link to the paper if you want to look at it later. There was a centrifuge machine in the Forensic Explosives Laboratory. As I said, it was a trace laboratory. What that meant was it was explosives free. To get into the laboratory, I would have to go through 3 different rooms. The first room, I would change my outdoor shoes. I would put on different shoes, so I had separate shoes that I would wear in the laboratory that had been bought in sealed packages. The next room, I'd have to wash my hands and my arms, and I would have to put something over my head, and I would have to sit on a bench and put an overboot on one foot, put it over to the other side, overboot onto the other side. Glasses or anything like that would also have to be washed. In the final room, I would put my suit and my hat completely covered in my gloves. I would then have to swab every part of my body using a piece of cloth. Now, you might have seen them at the airports. Has anyone ever been through airport control and they've stopped your bag and they've got a piece of cloth and they've swabbed it around your bag, then they put it in a little machine at the side? Has anyone ever had that happen to them? Look out for it next time you go to the airport, because they have them there. So you have to swab, and they're checking for explosives. So I would have to do that, and only if I was explosives free could I go into the laboratory. We were looking for such tiny amounts of explosives, nanograms. Okay? Nanograms, just to try and get your head around that if you're not sure. If you imagine the size of the Earth, And if you shrunk the Earth to the size of a football, if you shrunk the Earth by the same amount, the football by the same amount, now we're talking nanogram size. So absolutely tiny. We're talking trace, very small amounts. So we have to know that there are no explosives in the laboratory to contaminate our samples. They discovered in our centrifuge machine, which is a piece of kit that basically it spins and you put the samples in, they found 30 micrograms, which is bigger than a nanogram, okay, significantly bigger, 30 micrograms of RDS, which is an explosive, actually on the centrifuge. Now, what that meant was that any case that had been tried since that centrifuge had entered the lab in 1989, people could then argue that any explosives found came from the centrifuge machine and not from the potential suspect. So every case where someone had been, I think there were about a dozen cases where people had been convicted based on this evidence, okay, based on this evidence, sorry, battery was low, would therefore could be overturned. So they could actually go back and overturn the conviction. So they actually had an independent advisory board, had to come in and do tests and look at it all. And they came back, fortunately, and said, no, it was fine, the methods are clear. But that meant that any time one of our experts went to court, there could be questions about their techniques. So that led me to what I did when I was there as a researcher. It's not going to work. I was a researcher for my 2 years there, which means I didn't do casework, I didn't do live casework. But what I did do is research our contamination procedures, our anti-contamination procedures. On the site that we worked, we had bulk explosives. What that means is we had amounts of explosives that you could actually see. I went and carried out, you follow something called a standard operating procedure or standard method. So you have to follow exactly the same thing each time, so that when you stand up in court and give your evidence, you are saying, I'm using this tried and tested method. My paper, this is a published paper in the Journal of Forensic Science, I tested these methods. I tested them in our trace laboratory. I tested them in a room surrounded by explosives. And if you follow what I proved, and this is not working at the moment, but we'll do it later, what I proved, and if you want to have a look at the abstract, it will be available, is that if you follow our procedures, you will not contaminate the sample. So any scientist now from Forensic Explosives Laboratory who goes into court, if they are questioned about whether or not their procedures are up, they can quote. In fact, I met up with Andrew Crowson, who was one of the Trace Lab manager, and he said, you have been quoted in court. This paper is now quoted in court to say our contamination procedures are good enough. So you have to back it up. Oh, no, I just pressed the wrong thing. That's going to confuse it again. As I say, if anybody wants to see the paper, you're welcome. I've got a copy. Moving on then from explosives, that was my area, but I did do a forensic science masters, which means you have to look at all areas of forensic science. A lot of science, a lot of the stuff we do in forensic science nowadays is new. They used to use something called the Bertillon system. And the idea with this was that adults, once they were grown, their features, their sizes didn't change. And they would measure parts of the body. So, for instance, here they're measuring from elbow to fingertip. They would measure the length of the nose, length of the eyes, the head, circumference of the head, all the different body measurements. Now, they did this by way of identifying someone. The problem they would have with this, of course, is they're assuming that nobody changes at all throughout their adult life. But also, this wasn't something that could necessarily be compared to a crime scene. People don't leave behind a whole arm print, you know, or a full body face print. It wasn't that they could use it as a comparison. They could, of course, if I arrested one of you, Davia, is that your name, is it? If I arrested you 1 year, and then a year later you came back, but you've got an alias, and you're now going by a different name, could compare with these measurements. I know that it's you, and I know you committed this a year before. So it did have its place, and they could use it, but it was limited in terms of actually finding the person in the first place. However, the guy that came up with this system was a pioneer for lots of forensic science stuff that came up. He then went on and started people looking at fingerprints. Now, fingerprints, do you know how they're formed? Then I'll tell you how and when they're formed, fingerprints.
You have grooves in your fingers and there is an oil secreted by your fingers which will get stuck on surfaces.
When were they formed? Do you think?
Fingerprints are formed at birth.
at birth. Before that, they're actually formed by about the 5th month of fetal development. So they're formed by the movement of the fetus inside the womb. That's why no two people have identical fingerprints. Identical twins that have the same DNA have different fingerprints because they have a different experience in the womb. So their fingerprints are very different. This means that we have something that we can compare. Okay, this means that if you've got someone's fingerprints, you would all have, when you're getting your Emirates ID or getting your e-gate, your fingerprints taken. You had that, you've all been and done that with your Emirates ID. And you have to actually do your biometrics and your eye scans and your fingerprints and things. When you take your fingerprint, it goes right round the finger. Now, fingerprints can be, they fall into different categories. Visible fingerprints, I spoke earlier about the fingerprint in blood. So if you leave it in a sample, so mud or dirt or blood or something, so it's one that you can see, a visible fingerprint. But there are also latent fingerprints. These ones might not be visible under normal light, but if you use something like a UV light, they show up. There is oil. The sebaceous glands on your hands are releasing oil, and that's why you leave the fingerprints behind. It's actually the oil impression that you're leaving behind. It does differ. If you've just washed your hands, you might not leave as many fingerprints. If you've just touched your face and you're like me and have oily face, you might leave more fingerprints. Okay, but it makes a difference. You can't always see them. So at crime scene, if someone goes to the crime scene and they're trying to look for fingerprints, they won't dust the whole place. If someone broke into the library, okay, someone broke into the library through that window, I'm not going to print the whole library to try and find them. But I might look at the area that's been broken and see if I can find them relevant there. If something was taken in this stand, for instance, I would focus my energy and look there. You don't dust everywhere. But we use something like aluminium or an iron-based powder to physically brush, try and get the fingerprint. We can then lift the fingerprint using tape so that we can keep it, or photograph the fingerprint. Bertillon, who I just spoke a minute ago, one of the things he did was start to put a scale in a picture. So if you took a picture, he'd put something next to it of a known size so that you could compare and get some idea of the scale. That was one of the real key things that he changed in forensics. If it's a fingerprint on something that's a smooth surface, you can use something called ninhydrin spray. The ninhydrin spray reacts with the amino acids, and then that actually shows up in this colour as purple. So you can have a look and visualise it. So fingerprints don't have to be the visible ones. How much evidential power they have will depend what it's in. If it's in the victim's blood, you know the person was there at the crime, or at least after the crime had been committed. I'm going to talk a second about what it can mean a fingerprint being there, whether that is evidence or not. But no two people have identical fingerprints, but they have similarities. This is called a whorl, this bit here that goes right round, an arch and a loop. You do have a tented arch as well, but these are the three key bits to do with fingerprints. And if you look at your fingerprints, you'll see that you'll have different parts on them. They have more names than that, okay? It's difficult for us to see just looking at it like this. It makes it much easier to actually take the print, but then you can start comparing. So again, a fingerprint on its own doesn't tell you who's done it unless that fingerprint is on a database somewhere to compare it to. It needs to be a comparison. There's been some changes in forensic science. So what actually makes an expert? It previously used to be a case of, I've been doing this for a really long time, therefore I am very good at it. And that's what they used to believe. So as an expert witness, someone would stand up in court and they would first think, how long have you been a forensic fingerprint expert? I've been doing it for 25 years. Or then you must know what you're talking about. They've now realised that you can do something wrong for 25 years if no one corrects you. And being an expert doesn't just happen because you've been doing something for a long time. So they've changed that a bit. When they look at expert testimony and they look at what makes someone an expert, they're going to look a bit more at what they've been involved in, their credibility. But also, they've actually started to put some conditions on the fingerprint. They will actually look for matches. So here we've got, this is a rolled fingerprint. This has come from the suspect, and this is taken from a rear view mirror. So they're actually looking for points that match. And now within a fingerprint expert, instead of someone saying, I've been doing this a long time, I know what I'm talking about, they have to find a certain number of matches between the prints to say that they have a positive identification. So forensic science is changing. They're actually, the way they're looking at it, what makes an expert. When I decided to become a forensic scientist, I wanted to stand up in court and say I was an expert, just because I thought it sounded cool. I didn't get that far. Okay, but to be an expert, to really be an expert, and I have friends back in the UK now who do this on a regular basis. They say it's terrifying, because whilst they're staying up saying one thing, there is at least half the people in the court that want them to say something different. So having these different points and having these different points of reference is what makes them the experts. Oh, going the wrong way. Now, this man here was convicted of burglary and theft, and stole thousands, tens of thousands of pounds worth of jewellery, I think it was. They found his fingerprint on a vase. They found his fingerprint in the house. And he was, I don't know the full case details, okay? But if you research him, Rob McNamara is his name, the fingerprint was a really strong piece of evidence. It was essentially what linked him to it and what then put him away. He went to prison. I think he served 2 years. But he protested his innocence the whole way through. And he said, no, it's not me. I didn't do this. Even afterwards, he has tried to appeal and overturn the conviction on numerous occasions. And the reason being, the surface the fingerprint was taken from, they said it was taken from a jewellery box. So from a wooden surface, which would be relatively rough. However, the fingerprint experts and a member of the police actually left the police so that he could testify on behalf of this gentleman, said that actually it was taken from a smooth surface. This man sold very expensive vases in pretty near where the crime scene was. One of the vases that he sold was found in the house. The dispute is that the fingerprint actually wasn't on the jewellery box, it was there from a purely innocent perspective on a vase that he had sold the people that lived in the house. And when they've taken those fingerprints, they've been wrongly labelled, not necessarily with any malicious intent, but wrongly labelled so that perhaps they think it's from the jewellery box, but it's not. But this man, still, as far as I could find when I was researching, it has not been overturned. So he still has that record and it still says that he was guilty for theft based on a fingerprint. Fingerprints are unique. DNA is not. And I'm not just talking about identical twins. Okay, identical twins have the same DNA. But DNA evidence is a statistical probability. It is not an absolute. Okay? But it is used and it is portrayed as absolute proof. And you've got to be very careful with that. There's something called the prosecutor's fallacy. If you're good with your statistics, better than me, please look it up. So prosecutor's fallacy is something that is often, people will say, right, there is only, 99.9% chance that this person is guilty. So, and they just basically muck up the statistics. But DNA is done on the basis of looking at tiny areas. I haven't got time today, but if anyone wants me to go through any more science on the DNA stuff, I can if you at another time. Do you know who this guy is? It's from the Making a Murderer programme. This is Stephen Avery. Now, Stephen Avery was convicted in 1986. Guys, can we turn the volumes off the phones, please? He was convicted in 1986 of a sexual assault on a woman. He was picked out in a lineup. She identified him, positive ID, as being the person that had attacked her. And he went to prison. They had, at the time in 1986, they had some scrapings from underneath the victim's nail, and they found some hairs. But they did not have the evidence to be able to actually analyse it. So in 1986 he was convicted. He always said that he was innocent. Several years later, I think it was about 2000, they actually managed to analyse the skin underneath the fingernails, and it came back not as Stephen Avery's. He tried to appeal and got denied, and they upheld the conviction. In 2003, and this was a sexual assault, so they actually found the hair in the pubic region of the victim. They analysed it and found the DNA of someone else. They actually proved the identity 18 years after the effect, and Stephen Avery was then released from prison. Now that's the power of DNA evidence 18 years afterwards. If you haven't watched the programme Making a Murderer and you're interested in this, it is fascinating. I haven't got time again to go into what happened to this man next. But how that is changing, there have been a number of convictions that have now happened from evidence that was collected before we have the science to work with it. It's really changed convictions, but it can also go very wrong. He has to go through another trial where there's been a chain of custody issue. It's quite shocking. Paleontology. Now, the problem at crime scenes is that people very rarely leave evidence that is big and bulky around for you to analyse. The evidence that you tend to look for at crime scenes is small, very tiny. So paleontology is the study of pollen, spores and other microscopic compounds, different things. This again is very powerful, and it has to be, people are experts in this area. When I did my Masters, I was actually lectured by the person that investigated this crime. So this is Holly Wells and Jessica Chapman were missing. So it's back in the UK. There was a huge scale hunt looking for them. I remember it on the news quite clearly. And eventually they found their bodies. And when they found their bodies, they then started to build the case and build the evidence. The evidence is never one thing, okay? Forensic scientist is not one forensic scientist who solves the whole case and gets the bad guy. It's not how it works. It's the different pieces all over the place. They found, in the area of woodland that the two girls were found, had some really distinct wildlife, distinct trees with distinct pollen. They found about 68, I think it was, types of this combination. And imagine finding all 68 in one place on someone called Ian Huntley's junk. So they found that combination of pollen on that thing and put it in there. They also found fibres, tiny fibres. We're not talking visible. If you know these football shirts, it's not like they're shedding lots of material. But they found tiny fibres in all of these areas associated with the suspect, Ian Huntley, who was then convicted. It's the combination of all of this evidence that makes it powerful. No one piece on its own. Some holds more weight than others. Fingerprint in blood, perhaps more than a fibre found somewhere else. But the real key thing with forensics I want to get across to you really is it's this combination of different science and any science to do with the law. I have a friend in the UK who's a document analyst, so she will look at documents. I've got a friend who's a DNA analyst. She also worked for the Met Police when the tsunami hit and they were trying to identify bodies in different countries that were hit by the tsunami. She was coordinating at the UK doing the DNA test to try and see if they could identify bodies. I've got friends that are fingerprint analysts, drug analysts. There's a huge range of things in forensic science. Now, I'm going to stop there in terms of new stuff, but if you have any questions for me, have I got my timings right? It's half an hour. What time are you expected to go on to?